Hello, everybody. Thank you for joining us today. My name is Emily Kuda, and I'm Percona Senior Manager of Marketing Programs. We're going to get started in just a moment. Can you raise your hand using the hand icon located in the control panel to let me know that you can hear me okay? Oh, great. All right. So next, during this webinar, you will be on mute. If you have any questions during the webinar, go ahead and enter them in the questions field within the control panel. At the end of the webinar, we're going to take time to answer as many questions as we can. In addition, a recording of this webinar will be made available to everyone within 48 hours or less, along with the slides. I have made a copy of the slides handy in the handout section. So you're welcome to download those now if you'd like to keep those handy. So with that said, I'd like to thank you for attending today. We're going to be talking about developing an app on MongoDB, tips and tricks presented by Percona software engineer Tim Vaillancourt. Take it away, Tim.
Hi, everyone. So my name is Tim Vaillancourt, and I am now a software engineer at Percona, but used to work on kind of doing reviews of architecture of Mongo deployments and some consulting. So this will be useful. This talk will be useful for developers because I want to explain a lot of problems to avoid with Mongo in advance. So let's start with security. Sorry, I went through that a bit quick. Authorization is becoming required in Mongo, and that's important because it secures the system. We advise that you use a different application a different user per application in read-write only mode, so that it has limited access to admin commands, but can still perform most application tasks. If you find that that's not good enough and you need more than read-write, you can always add to that, but I think it's pretty unlikely that your application would need anything more than read and write access. It's rare to see that. The built-in roles that Mongo comes with are read and write based, so we just talked about that. Administrative roles for different administrative features, backup and restore, and kind of more admin features, roles that you probably don't need in your application usually. When you're writing your application, and the reason I'm starting with security is that's becoming kind of one of the more important topics with organizations in the last 2 years. Make sure that all the teams that are operating your application are aware what is sensitive in the app, especially in big organizations where your network team and your database team and your development teams might be separate. Sometimes the developer is the only person that knows that there's something very sensitive in the application, and the DBAs and network teams aren't aware at all. And make sure they know that. Maybe they don't need to know what it is, but just aware that there is something sensitive in this application. I'm going to operate on the assumption that if you're developing the app, you might have a different team running Mongo. That's kind of a 50-50 or kind of back and forth, I find, with Mongo because it's more of a DevOps database. But let's just pretend you had a different team running the database 24/7, and you're the person writing the application. Make sure all those teams know that if you have credit cards in this database or something sensitive like that. Maybe it's not important to you as the developer. Maybe it is that you can enable the SSL connections on Mongo. That's probably what you would do, whichever team's responsible for it, to ensure that someone listening to the traffic of Mongo replication isn't going to see whatever sensitive data is going through it. Also, the client traffic can also be restricted with SSL. Also, encryption at rest is possible with the MongoDB enterprise binaries, and you can also use community or Percona server for Percona's MongoDB server with block device encryption using open source tools. You can also do that. A new feature in 3.6, and this is just wrapping up security, I think, is the ability to restrict IP addresses. So that's the last little thing I would add is if you know the IPs that your application servers will connect to your MongoDB servers, just add those ranges here in the bold example I have at the bottom as the client source IP restriction, and you're going to make a smaller attack surface for your app. So enough dry security stuff. That's probably a good start, but definitely the important parts mostly would just be use authentication at the lowest privilege possible. Read-write probably. If you have a read-only app, just read, and also make sure that your data is encrypted somehow. So schema and performance is really centered around a lot of choices that are made in development early, or maybe not early, but before the application sees any serious traffic. So the biggest mistake I've usually seen in applications that is usually hard to fix after it's found in production is incorrect data types. And what I mean by that is maybe incorrect is the wrong word, but inefficient, where numbers are stored as strings, or dates are stored as quoted strings. Booleans are stored as quoted true, quoted false. Those are usually things that are hard to fix when you have a terabyte of data or many terabytes of data written into the database in production, but very, very simple to fix at development time. So one thing I would look for is if you're ever in your Mongo shell and see quotes around a number or quotes around really anything, that means it's a string, and it's storing very inefficiently if it's a number. For example, the number 1, 2, 3, 4, 5, 6, 7, 8. I guess that's 1 billion something. I won't try. That number in quotes would actually store 25% less space if it was stored as an integer instead of a string 1, 2, 3, 4, 5, 6, 7, 8. So that's just one example. This bottom JavaScript, if you were to find this in an application in development before it went to production, you wouldn't really want to run this in production, but this for each loop that I have in JavaScript here would convert a string integer into a real integer on an entire collection. So that'd be a nice thing to do if you found that in development and said, whoops, I'm storing an integer as a string. You can just run this little JavaScript snippet that will also be uploaded after, also in PDF form here. So the key is just look out for strings. Don't store real data types as strings, because Mongo has rich data types like dates, booleans, integers, floats, things like this. So I've already said it more on the slide. Strings, that's just an example, 52% less space. If you stored that date, that is an example in quotes there, that would store half the space basically. Same with the Boolean true as string. So enough about that, but that's a really important one. Do that early. Run your app, run some unit tests, make some data, and look at the documents and just say, that shouldn't be quoted, and then go from there. Another thing is DB refs. Mongo isn't really a relational database, but you can use DB refs, which instead of copying a document from another collection into say you have a users collection and a orders collection, and every time an order is written to the orders collection, you're copying the user document for lookup speed. You could, if you wanted to save space, use a DB ref, which just causes your application driver to do 2 reads, basically almost like a primary key reference in MySQL or relational databases, that it'll look up the both parts, both the order document and the user separately, but merge them at the client level. So that would basically reduce the overhead of storing the user document over and over and make the read request possibly a bit slower. So it's a trade-off there. Lastly, number long was added in 3.4, which is a higher precision floating point data type that you could use after 3.4. It's a bit more precise, and unfortunately I don't know the details about that, but it's how precise, but it's a more precise floating point number than the previous. So indexes are extremely important. One thing I didn't add here is there's a built-in index in MongoDB. So if you write a document in MongoDB, you'll probably notice that there's an _ID field, unless you specified it yourself, that is kind of a randomized object ID hash. And so by default, Mongo is always adding an index to your collections, _ID. And if you want to, you can actually refer to that ID in your application and get really good lookup speed because you already have that index. But let's pretend that's not good enough for you, and we're going to add an index to your application. So how will we do that properly? Let's look at that. By default, adding a collection is going to, or sorry, adding a index will lock the collection until it completes, because that's just the most correct way to ensure everything has the right integrity. But there is a background true flag that you can add to indexing when you use a create index command that will make it run in the background. And this is maybe not so important for applications, but I have seen applications create their own indexes, or at some point someone needs to create an index when it's rolled out. So I just wanted to mention this part, that background true, while it does not block the collection, it can have kind of unpredictable performance impacts. So if you have maybe an upgrade to your application version 1 to 2 that needs indexes rolled out, it might be better to take members out of the replica set and apply the index if you have a lot of data versus using background true if you have any upgrade scripts or anything like that. There's a few reasons written here, mostly the unpredictable performance impact. Again, thinking about indexes or thinking about how your data is going to be used in advance pays huge dividends, because if you add indexes to an empty collection, it's free. It completes right away. It's really, you need to worry about adding indexes in production when you have hundreds of gigabytes or terabytes of data that you want to worry about background true indexing. If you're just starting a new app and just deploying it, just run regular index commands. I know I mentioned drivers auto-creating indexes, and I've just written here avoid them because I have seen that create problems in production for various ops teams that an app restarts and for some reason creates an index that shouldn't be created anymore. It's probably better to have a discussion, a group discussion, and plan a release with a, with some rules and some review, instead of having the application do it, usually, because of the impacts I mentioned on the last page. Too many indexes can hurt performance. That's probably pretty common in most databases. The main things that happen also on reads are that the optimizer has to look at more indexes or more plans. So if there's 10 different indexes that could answer this query, it has more work to do. But perhaps the biggest problem that I see, or I feel about too many indexes, is the wasted disk space, and most importantly, the RAM space that's wasted. Because indexes are often pulled off of the disk, they're using RAM. Even often, if you're not using them often in your queries, just the optimizer looking at pieces of them or different things like that actually just cause a lot of wastage in the RAM. The next thing to think about with indexes is what direction should they be. So if you're going to sort ascending, make sure that your indexes are added in an ascending order. I don't know if that's common in all databases, but Mongo actually has a direction for indexes. So try and match that, and it actually has less work to do. I have an example of that on the next page, I believe. Yeah, that's a great thing for efficiency. And then I think on the next page also, I mentioned the most important key here, that tied back to data types that we talked about a few slides ago. The size of your data types affect the size of your indexes, of course. So back to when I said that you could store that date in half the space, that actually means half the index size. So imagine that translates to RAM, basically. So if you have a gigabyte index and you're storing string quoted dates, that gigabyte index could be about half that size, 500 megs or so. It's so important that it has its own slide here. In reality, it just didn't fit on the last one. Indexes, compound indexes are important to look out for. You see those in most production databases. It's rare to just see singular indexes on everything. There's almost always a compound. And anyone who's not familiar, a compound index is multiple keys kind of concatenated together in an index. Mongo reads compound indexes like other databases left to right. And that becomes very, very important in the examples below here, that if you have duplicated keys in the left to right order, those are actually duplicated indexes. And just showing an example maybe just makes it more clear that the 4 indexes that I have on these bullet points, just second to the bottom on this slide here, are all duplicates of the first one, because the first 3 keys, username, status, and date, are in the first index. All indexes under it are actually duplicates because they're just asking for the same 3 keys. Each one is asking for 1 less. So what I mean is, if you have the same pieces of a compound left to right in 2 different indexes, it's very likely that you're actually duplicating. And one index that is read left to right piece by piece can actually satisfy it. And it's actually called partially reading. So this first index is the key here is the first index is really the only one that would be needed in this list of 4. You could drop all 3 other indexes and save a lot of space. The optimizer would have less work to do and still get the same performance. Your query efficiency is something that MongoDB and Percona both use as a term, and that's really just a ratio of how much scanning a query does on disk versus using indexes. The ratios are just written here, and this is just an example of it in Percona's monitoring tool that I think we're talking about on the next slide here. But just as an example, if your query scans 100 documents and returns 1, that would be kind of an efficiency of 1% or 0.01, and that's kind of how we look at it in PMM, which I'll talk about later, our monitoring solution for Percona. The other thing about query efficiency is sorting. It is another thing that to worry about, basically, for its CPU intensive operation. So it's common that you do need to sort something from ascending to descending, or you've queried 10 documents and you want it to be sorted in order of items. That can cause some CPU intensive operations on the database. You might want to think about moving that into your application if you have a lot of them. If you have, let's say, 10 application servers and only 2 database servers, or because this is Mongo 3, it might be a better place to do the sort in your application. But just keep that in mind. If your CPU is really busy on the database, someone tells you this, maybe move some sorts to the application or just add some more CPU. But also, we'll talk briefly about sharding, but sharding also, sorting can cause some CPU overhead because it has to merge results from many shards. So I talked about the direction of the sort here, just in green. I have an example index and query, one that's matching the sort, the -1 cost. So the query on DB items find for ID 1, 2, 3, 4, I'm sorting on -1 cost, and the index just a line above has ID cost -1. So that's matching the direction of the sort. And of course, the red one on the bottom, the index is cost 1, and I'm sorting on cost -1. That's a backward sort, and it's a bit more inefficient for Mongo to do. I said PMM is coming up, but I guess I rearranged some things. So bulk writes is another feature that you could do if you're doing a lot of ETL jobs to import lots of data at once. Not too common I see in apps. Usually an app is just working on a single user doing something. But if for some reason you had to import hundreds of documents at once, thousands, you can use the bulk writes API, which almost all drivers have as just bulk write. And basically you can just keep adding inserts or changes, and at the end say fire or whatever the function name will be in your driver, and it sends it off. But the thing to be worried about is unordered mode. You can make the bulk write unordered, which means it'll just try and write it all in whatever order it wants. And if it receives an error, it just ignores it. I think it might return it to you, but it doesn't actually stop at that error. So it's kind of not fun to recover from that kind of problem in your application. I would probably just use ordered mode. If ordered mode hits an error, it's just going to stop and return an error, and you're going to know at what point that error happened to continue. Some anti-patterns that I see a lot in applications, this is a good slide to think about, is not specifying a list of fields in a find. So Mongo, just like MySQL, if you do select star in MySQL, you're going to get every column on a row. In Mongo, if you do a find on a filter with no list of what fields you want, you're just going to get an entire document, which could be up to 16 megs in size. And imagine you just wanted, I think I have my example here, cost and available from a document. Let's say we have a collection of items, and I just want to know the cost of an item and is it available, or how many are available. But that document could have many other things in it, maybe, like I say, up to 16 megs of things. In my example here, I'm specifying I want ID 1234. In the second braces, I have cost 1, available 1, which means I'm going to get 3 fields back, not 2, because ID underscore ID field will be returned because that's the default index field that I mentioned earlier. You could say underscore ID 0 to get rid of it, and then it really would be 2 returned. But here, I'm just returning 2 fields. That's much easier on the network and the database to do. Also, if those two fields were indexed, that would be a covered index read, basically. It wouldn't hit disk, it would just hit the index, which would be awesome. Another anti-pattern is using $where. That causes a lock. Or really using JavaScript at all in Mongo causes more locking than you might expect with modern wired tiger and aggregates. So I would just try to avoid using $where. That might cause locking that you didn't expect in the collection. Maybe just for 100, I think 100 doc ranges, but also there are points where I think it full locks the collection. Another anti-pattern is a lot of ands and ors, and by a lot I mean hundreds or thousands, where you're querying for items in or and huge list, so maybe 100 or 1,000. That's not going to work so well on any database that isn't really a graph database designed for that kind of thing. It will work on any database. It's just how efficient will it work. So what I'll say for unbounded ands and ors is try to make them bounded. So if your app allows any number of ands and ors, just break them into pieces of maybe 100 maximum, unfortunately. Because there is a limit to the system, and unfortunately, one day a user might just say all of these 10,000, 100,000, and kind of bring the system to a halt. Another is MapReduce. And actually, sorry, before I continue, just anything unbounded in your application is a good thing to try and avoid with the database, because again, there's always a limit to the database, and someone being able to pass any number of something down to it is not going to help it very much. So MapReduce, just like JavaScript, MapReduce is using JavaScript and does a lot of locking. Try to use the aggregation framework that we'll talk about. And I already talked about unordered bulk writes, that error handling can be unpredictable, just not very clean in your application if you let it run in parallel and not stop on the error. Aggregation framework is one of the most exciting things about, I think, as a developer for using Mongo, because it's such a powerful tool for looking at your data. And there's entire books written on it, so I can't actually go into much detail in this hour about just what it does, because it expands every release and has more stages added to it. But let's talk about what it does. It's a pipeline of stages that runs on a MongoDB collection on the server itself. So you can do some really powerful things that a lot of infrastructures are doing in Spark and other tools that are outside of the database, pulling the data into Spark, processing it, writing it back somewhere. You can do a lot of that stuff right on top of the data without ever having to send it over the network to something like Spark or these other aggregate systems. And it's getting more and more powerful every release. The stages are processed in a pipeline, so each stage passes its result on to the next, so that you can send down the result into whatever you're trying to get it down into. And it has a lot of different stages that I've already mentioned many times. I'm just going to go through some examples that you can, running it on a collection, you can match documents that you want to aggregate, which is important because by default, an aggregation runs on an entire collection on everything. So match is great. Specify it first to say, I only want to run it on sold orders or whatever your application is looking for. Group is similar to group by in MySQL or SQL databases, where you can group by, probably a more powerful group by different conditions that we'll get into. You can count the number of documents that match something in the stages. Project, bucket, and bucket auto is great for faceted search that I've written a blog about, that you can bucket your documents based on bucket boundaries and different expressions. You can do geo-near with geo-proximity on maps, basically, graph lookups. Sample sizes, so random samples of your collection, unwinding arrays, and then maybe the craziest one at the end is run many aggregation pipelines within a single stage facet, which almost hurts my mind to think how complex that could get. So you can write very, very complicated pipelines in aggregation. I'm going to wrap it up pretty soon because the possibilities are almost too endless. But within each of these stages, each of these stages are able to access these variables I have on this page. And these are just some of them that are able to process numbers, less than, greater than, min, max, standard deviations, floor and seal, days of the weeks, time processing, the difference between this timestamp and that timestamp, concatenating strings, splitting them. So it gets very crazy what you can do with the aggregation framework. And it's also able to write out its results back into the server as a new collection. So a very efficient thing. And great to look at if you have some more complex usage of Mongo that isn't just kind of get and set lookups. This book on the right is good to look at, and also the MongoDB documentation about aggregation. Data integrity. When you're writing your application, you probably don't want to lose all of its data. We can kind of skip over this slide, but this just explains how Mongo makes something durable on disk. Not too important, but it'll become important in the next few slides. This is really typical of any database, using a write-ahead log for journaling. So in Mongo, the replication is asynchronous, but you can actually pretend it's synchronous in your application. So if you have a really, really important write to do, like sell this book or sell this car or whatever, something you really wouldn't want to roll back or have messed up somehow, you can actually tell on a per query or per session basis in your application how many nodes or how consistent this write is going to be. And that's a really powerful thing that Galera doesn't really have, or sorry, Percona server for XtraDB, because you're kind of set on how many nodes you have. Cassandra, I think you can specify the replication factor of a new collection or table, but not on a per query basis, I believe. Don't quote me there, but I think, but it's amazing how flexible this is, that the write concern in Mongo per session or per query, we can say 5 nodes need to acknowledge this, or everyone needs to acknowledge this, or just one node needs to acknowledge this. How you do this is using the write concern part of your driver. Each driver will do it a bit differently, but write concern, you can specify either the number of nodes to acknowledge or a majority, which is usually what most applications will want, which is just half the nodes plus 1. So if you have 3 nodes and you say write concern majority, 2 nodes need to write it before it returns to you. And you know that if there's a failover, a crash of one of the nodes, the second node that wrote that document is going to win the failover by default because it'll be ahead. And that write is still going to be there, at least on one node crashing in this case. You can also specify, here's where journal comes important, you can specify should it journal the write or not. By default, a write is never journaled in Mongo, which sounds kind of scary until you think that you're actually using the number of nodes as the quorum. So if you're saying majority, yes, it's not written to disk on both of the nodes that were majority, but that's a pretty good protection. If that's still not good enough, you can say journal true, jtrue, which means both in a majority context, the majority nodes will write it to disk, not just to memory, basically. And again, I'm just mentioning again, write concerns are not durable, jtrue. In 3.4, that's changing. If you don't specify a J flag, it will be true by default. So that's actually a really good thing to mention now, is that that's changing. And if you don't specify it, Mongo is going to make it a journaled write by default, which is probably good if you don't notice it. If that concerns you, you can always say J false in your application per write or per session or per connection. Read concern is basically what you'd expect now that you've heard about write concern. You can use read concerns. And one concern I hear a lot about using Mongo on applications that need very correct results to the moment is there can be lag in Mongo. So I can't read from my secondaries. There might be 4 seconds of delay or something like that. If correctness alone is what the goal is, read concern is a great feature because you can actually specify on a read how many nodes have to agree on that result. So you can actually say with majority reads that you can read a consistent result that all the nodes will be able to agree on. And maybe that will answer some of the consistency concerns that you might have. Without using read concerns, you're going to read the most recent copy of whichever node you're talking to, where read concern can actually specify a consistency of the read across the entire replica set. The main use case for that is that if the replica set has a failover, that means that whatever your application read will remain true forever. Whereas if you're not using any read concern and the primary was maybe a minute ahead of everyone, that minute of data could be lost, and your application may have read that bad minute and thought that it was written, if that makes sense. So if that concerns your application, you would basically want to use a read concern majority here and a write concern majority, which means if any node crashes, we're still going to always read and write consistent results. It's a great feature. Replication, this shouldn't be so important for the developer, but the size of the op log may become a problem with your application if you do enough writes, and you might hear about this. The op log is just a cap collection that Replication is using and writing changes to. It's also useful to know about it because you can see the writes that your application is doing, and the op log is located in the local database in the collection oplog.rs. Also, when I mentioned lag earlier, what I meant is actual the delay between different members of the replica set writing changes to the oplog. So every member of the replica set reads the oplog of the primary and writes the changes that that primary was doing to itself. And the lag in that process is what we mean when we say lag in Mongo. So up until this point, I think we've made some good choices in our app. That's a theoretical app now. We've looked at data types, looked at the indexes, the security of the data. Can someone listen to the traffic, things like that. We might have a problem in production that, or not in production, in development that might raise some questions. Maybe just a query is just not indexed and very slow. And I'm actually alluding to the fact that we should be monitoring the application in development as well to find out these issues early before production. And we'll get to that because I've mentioned we'll get to PMM and we haven't yet, but we will. But first, let's talk about usual suspects. If you have a performance issue in development or really anywhere, my kind of triangle of suspects is usually locking, limits, and resources. And usually it's not any 3 of those or any 2 of those. Usually if you have a new problem, the database was performing fine and now it's not, your issue is probably going to fall into one of those 3 categories, which might help you kind of looking everywhere, running around everywhere. Maybe look at, can this be locking? Okay, yes or no. If you think yes, move into that category. But if you don't think it's locking, move on to limits or resources. And that's kind of how I've worked to save some time in investigations is if I don't see any sign of locking, I'm kind of going to move on and stop looking at collection level locking, document mutex, things like that. And maybe just look at, is the maximum connection set too low? And maybe there's no locking, it's just Mongo saying, hey, too many connections. And it can actually do a lot more traffic. Same with resources. If your disk is burning because it's just too much traffic, it's unlikely locking is happening at the same time. That's at least my experience. So that might help with your troubleshooting as a methodology. So usually when you hear about a problem on your application, the first thing you might want to do is just run db.currentop in your shell. That's going to show you the queries that are running right now on the Mongo server. Lots of useful information that you'll probably recognize right away if you wrote the query. You'll say, oh, there's that query I wrote because it's matching ID or something you recognize. And lots of interesting locking details and results coming out of there. You can also filter that. That's just an example of what it looks like. This could just be really useful for, hey, what's going on in the database right now? But that's not always what happens. Often you hear about a problem 10 minutes ago or you weren't there when it happened. So there's a feature in Mongo called the Operation Profiler, which is able to log slow queries or all queries if you set it to. I don't advise that. Probably leave it in the slow query mode, which uses a threshold of time to say, this query was too slow, I'm going to record it. And it records it to a collection called system.profile in the database that the profiler is enabled on, which is nice because you can just query it like a Mongo document. I think I have an example. And we'll get to it soon, but PMM uses that output, Percona monitoring and management, to actually show you how queries are performing. So this example on the right's a bit blurry, but that's a document coming out of the system profiler for a query that I did on wikipedia.pages, and it scanned 35,080 documents, and it returned, I think, I can't see how many it returned. I guess that got chopped off, but it used 0 keys examined, so it wasn't using an index. So that's just an example of what I would say when I looked at a profiler output. And the keys I just mentioned here are in bold on the slide here. Keys examined is an important one. That's how many document keys a query scanned to get its result. And documents examined is how many documents on disk were scanned to get a result. Usually you want keys examined to be pretty minimal and docs examined to be 1 or exactly how many you're returning. Also, the explain tool, just like other databases, you can see a query before it executes. I'm just going to go back a slide. The operation profiler logs a query after it executed. And that's really useful to know because this is showing kind of what the optimizer predicted, and the profiler showing the reality of what happened. So on this slide, I'm kind of showing you both of the, on the left, an explain output of the same query and a profiler output of the same query. And we can see different things about how the optimizer looked at the query and how the database performed the query, if that is useful to you. You can also get the same data out of the log files on the Mongo server, but hopefully you don't need to because that's just a bit of extra work. So here's where Percona PMM finally comes in. Percona has been developing some open source automation and tooling for monitoring databases, including MongoDB, MySQL, and I believe Postgres, I believe is coming or already has. And it's based on open source tech, and we're trying to make all of the troubleshooting steps that I just mentioned in this section a bit easier to do than all of the kind of fine details I just talked about. So we just have some examples of what you might see in the standalone instance of Mongo. You can basically correlate hardware resource usages like CPU and stuff with also Mongo usage because those two things work together. Very important to have them on the same page so we can see both operating system metrics and database metrics in the same place. But probably more importantly for developers is we have the query analytics component of Mongo that actually reads the profiler that we talked about on a few slides ago. So if you install Percona PMM, which is a server written in various Go and various languages packaged into a Docker container, you can hook the agents up to PMM, and basically they're going to send the profiler data of slow queries to the PMM server, and you as a developer will be able to visualize what you're seeing here in a web browser instead of having to hop all over your Mongo servers to look at performance metrics. We also automate, it's getting chopped off in this example, the explain of the query, so that it's very easy in development to just look at QAN, we call it QAN, or query analytics, and just see each time you run your testing for your application or load testing that everything looks good. Hopefully you don't see a new slow query or something that's scanning a lot of documents, which you'll be able to see with ratio in QAN. Using PMM in your dev process should be pretty easy. Just find somewhere to run it, maybe even your laptop, Docker-based deployment, so you don't really have to do much. Install an agent on a database, MongoDB here, develop your app, go look at the website, go look at QAN, and repeat. And hopefully move that to production because it's a nice tool to have there too. But at least here you'll be able to see as a developer without having to run all the explain queries and find queries on your profiler data, nice and quick how things look. The other things, more operationally, it's nice to have a way that people can look at that without having full access to the database shell itself, like SSH. Also, the queries can be normalized, and I think they are by default that we remove like usernames and passwords, I believe, from the output. At least that's a feature if it's not a default. I think I'm duplicating an example here. Other tools that you can look at for Mongo when developing are mlog filter that will chop up the log file, but hopefully you don't need to hop on a server with QAN or all these PMM tools is the goal. There's also command line tools that Percona writes, PT Mongo Summary and Query Digest, which is kind of a very simplified, Query Digest is a very simplified version of what QAN is doing. It will process your profiler locally on a server in a shell output, not as nice. Okay, so the fun part is scaling, I think, because that means your application is probably doing something good. So to scale your reads in Mongo, it's cool that Mongo kind of has what I want to say 2 knobs for performance. They're not that simple as just knobs, but I like to call it that. One is read preference. So read preference combined with replica sets is one way of scaling reads. So replica sets, I talked about earlier, are usually 3 nodes for consistency, but you can add up to 55 nodes to a replica set. Only one can take writes, but any member of a replica set can take reads, unless they're hidden, and a few other caveats. So when you write your application, unless the minor amount of delay is very important in replication lag, that delay, and you don't want to use read concerns, unless those things are true, I would always try and set your read preference to secondary preferred. And I've kind of underlined in brackets there recommended for read scaling, because what that does is it means your application is able to use secondary members for its reads. And I just said you can have up to 55 of those per replica set. So if you start with 3 members in your replica set and your app is a very heavy read database, it's just mostly reads, 90% reads, just keep adding replica set members. And as long as your application is using secondary preferred, which can be changed per query, just like write concerns and read concerns, you can kind of guarantee almost linear scaling of those reads, as long as you keep adding members up to 55, or it might be 50. Let's say 50 just in case, but that's quite a few. You can scale out those reads. That's how simply put I can give it. On the opposite knob or opposite side is sharding, and that's a huge topic that we have a lot of literature and other webinars about. But sharding is another way of deploying Mongo where there's multiple replica sets, which now become called shards, and extra system components, a metadata replica set, and routers. So it becomes a pretty big system. I think you need about 7 or 8 nodes minimum to set it up. That would then allow you to elastically scale writes. So with a replica set, let's take a step back. You can always add more members to scale out reads, but there's only one member that can write. If that one member is not good enough or can't take all your writes, you're going to have to move to sharding. And sharding, you should have quite a bit of literature about out there to look at. And this one's actually a good one at the very bottom of this page. Choosing a good sharding key will get you started in your application process. But basically, when you're using a sharded cluster, if the writes become too high on a single replica set, you can add more replica sets on the fly, and the data is balanced out by the cluster onto the new replica sets evenly. And basically, that write performance is added or even removed if you want from the replica set online very elastically. I don't recommend you go straight to sharding, especially in development. But if you're writing an app that you know that it's going to scale to social media scale, or you know no matter what, this is going to store more than a single replica set could ever do. Maybe think maybe more than a terabyte of data, more than half a terabyte of data per replica set is probably a good aim to have. Then start to think about sharding. And this blog is a great one to go to. And we couldn't cover all that in this talk today. So elastic deployments are pretty simple with Mongo if you look at it the right way with these features combined. So I'm just going to wrap it up one more time that when you're writing your app, as long as you use the right read preference, scaling reads should never be a problem, really. Well, tied with the right read concern if the integrity of that data is important to you, because you can always add and remove nodes from your replica set up to 50. And that's a pretty nice thing to go to from 3 to 50, quite a scaling number. If you need to move on from that, you could always add a caching tier in front of Mongo. I'm not really recommending that. That's just another way out. Or if you already had Redis memcached or some kind of caching tier for reads. And then also a neat thing about sharding, which I'll call scaling writes, is if you move to scaling writes with sharding, you're also adding read capacity every time you add a shard. So say you add another shard because you're running out of writes, you just added reads as well, because a new shard is probably 3 members, and there's 3 more members that you could read from that you didn't have before. So every time you add a shard, you're actually helping both read and write capacity, which is pretty nice. If that's not good enough, you could use bulk writes. We talked about that earlier, where you can bulk your write operations together, hopefully ordered so it doesn't cause a lot of problems in your app. Or you could use a queue for batching, tied with bulk writes, all sorts of neat ideas there. But really, there's no limit on how many shards you can have in sharding. So there might be a limit, but it's not a limit that anyone needs to worry about. Maybe 1,000 or more. That's kind of the two ways to balance out the data there. Lastly, with all this elasticity, this actually creates kind of problems with applications, because usually when your application starts up, you have a list of hosts to connect to. If you had 50 members of your replica set, you wouldn't really want to change your config file of your application every single time and have a list of 50 members. In my example here, without DNS SRV, there's 3 members, 3 host ports, and that's a pretty long string already, but imagine if it was 50. In 3.6, a new feature was added that uses DNS SRV records, and I thought this would be nice to talk to developers about, because this means that your application can use protocol Mongo plus SRV, which is at the very bottom example, and a single DNS name to get the entire list of hosts from your DNS servers. And that might sound like a small thing, but in practice on very large systems, I've worked on systems where we have 20 app servers. Every time you add a node to the Mongo setup, you don't really want to go change config files, or also have the application developers have to worry about restart logic and all the different problems that could happen by restarting the app or reloading the config files. So it's probably becoming pretty clear that that's a nice feature to use. So if you're writing an app, use the latest driver and try and use that feature if it's interesting to you, because if you're scaling Mongo up and down all the time in the ways that we just talked about with scaling reads and writes, it's going to cause a lot of changes in your configuration and in your config files that won't be necessary if you use the DNS SRV system, which really kind of answers the last piece of the elasticity, that now the application servers can find everything, even if it changes from 1 second to the next. So now we've reached the end. I just wanted to relay one more time that the biggest most important points were really data types and worrying about that early, adding indexes early because it hurts to add them after. And also, of course, security, that using authentication in minimum privileges from the start is great, because once the application is live, it's very difficult to switch to using security. It's very easy to add at the beginning and very difficult to add later. So yes, any questions?
Thank you so much for that, Tim. All right, at this time, go ahead and enter your questions down in the questions panel. We're going to take time to answer as many as we can. All right, so our first question is, we've seen the following problem with a replica set regardless of the read preference setting, if one of the nodes in a set is very slow but not slow enough to be excluded from the replica set. The reads are extremely slow. Actual latency is always defined by the slowest node in a set.
I guess to that, I would maybe first think that maybe read concerns are the problem. Of course, a node being slow is an entire issue on its own. But if you're actually waiting for the slowest member, that might mean that there's a read concern majority or all set is one thing I would think about. It also could be the way that your driver connects to the nodes. The driver may rule out nodes that are basically too stale. But the first thing I would guess maybe is that the read preference is set very strict, and separately finding out why that node is slow is kind of a separate investigation. But in this case, read concern would wait for the very slow node, unfortunately, and that's kind of a downside of read preference. That's probably, or sorry, read concern. That's good to bring up. That read concern waits for the slowest member, basically.
Our next question is, in your opinion, is Percona server for MongoDB ready for production?
Yeah, absolutely. I can explain quickly how that's done. So Percona server for MongoDB is a fork of the community server. So what we do is we basically, it's much more complicated than this, but we're basically copying and the latest release of Mongo and adding a whole bunch of enterprise features. But at all times, we maintain the same API compatibility, but we also make sure that our code doesn't get in common code paths. So what I mean is, if we're adding a new feature to the Percona server, it's going to be called under a command that's a new command and not one that is injected into the path. So what I mean is, we're never going to add something to the insert code that would change how insert works or things like this, because we want it to be a drop-in replacement. So where I'm going here is, it really is the same server with extra features. The extra features are heavily tested and QA'd by Percona, but if you don't use them, if you don't use those extra Percona features, you're basically using the community fork, which is basically the same level of reliability, stability.
Thank you. Let's see, our next question is, how to specify a list of Mongos in application config like we specify in MongoDB connection string?
Right. MongoS is basically specified the same, so you can actually use the SRV record support for MongoS as well. I would probably make that a different SRV record name, like maybe MongoS. Actually, that's probably the only SRV record name you would care about once you've deployed a cluster. But my point is, I guess, that you can also do the exact same thing with SRV records in MongoS, or not. You can just have a comma-separated list of hostname port for MongoS if you prefer to do that, but you lose the flexibility.
Thank you. Our next question is, secondary nodes when promoted as primary stops responding to queries. Rebuilding the data helped solve this issue.
Secondary nodes. That's, at face value, doesn't sound expected to me. That's definitely an interesting problem. Maybe Percona could help with, but let me try and think how that could happen. Basically, on failover of a secondary will be elected, and I guess you're saying the secondary that's being elected as primary is not responding. There are some things that come to mind that the new primary can actually have to roll back a lot of transactions. So if you were doing a lot of writes during that failover, the secondary that's taking over as primary may actually need to roll back some of those. Also, that's kind of the best idea I have, aside from also older versions have a kind of slower reaction to failover. So if you're using anything older than 3.4 Mongo, that might be expected, because there's actually faster or 3.2 and 3.4 made elections and failover a bit faster. But aside from rolling back the op log, we would need to know a bit more, and maybe contact Percona with data like the log file of that server and the version and a few more details, and maybe we can help.
Thank you. Our next question is, why would I choose to develop on top of Mongo instead of, say, I don't know, like MySQL?
Yeah, I think the main reason is if you have a very join-centric app. Well, there's many reasons, so let's start there. That generally I see a lot of MySQL apps needing to do a lot of joining between very different tables, orders and users and products and things like that, which are usually a very expensive operation, and also to a user of the database, a DBA or developer, we've got used to looking at databases this way with foreign key constraints and different tables and references, but it's actually not a very natural way of thinking about data, at least to me. So Mongo is kind of great for applications that are frequently joining a lot of data to create kind of a view of something for a user that could have actually just become a very structured, very nested and structured document, but a document that could actually be looked up as a single primary key. And that's kind of one of the big focuses of NoSQL, is really taking the speed of primary key lookups and seeing how close to that can we get. And what MongoDB allows you to do, or really any document database, is kind of bring the join to the primary key, so that all the relationships are satisfied in a single primary key lookup. Secondly, MySQL doesn't have a real elastic plan of kind of saying, oh, whoops, I need more read capacity. Yes, you can add more slaves to MySQL, but if you exceed the primary, or sorry, the master in MySQL's write performance or RAM or CPU, all you can do is make that box bigger. You can't add more of them. Where in Mongo, you can say, I want 1,000 shards now. MySQL, you could do that with some automation around MySQL, but not within MySQL today. And I think the other thing is just there's a more richer query language on top of Mongo now with the aggregation framework. There's a lot of things that wouldn't natively be possible in the MySQL query language that is now possible in aggregation framework. There's a lot more benefits, but I think I'll leave it there. Performance may be the last one, yeah. I think actually, sorry, the last one I'll just leave is it doesn't paint you into a corner. The knobs I was talking about, where I feel good that I can always tune the consistency, the read capacity, the write capacity. You always kind of have a tool to get you out of a tough spot in that way.
Thank you. Well, we are at the top of the hour. If you do think of any questions that you wanted me to pass along to the presenter, feel free to send me an email at emily@percona.com. Thank you so much, everybody, for attending today. Huge thanks to you, Tim. Thank you so much for presenting. And we hope to see you on future webinars.
Thanks, everyone.